Hello, exceptional students of Mrs. Whitney's. So this is unit or section 9.3 and is the surface area of cylinders. And there's this big, long, huge, complicated formula for finding the surface area of a cylinder. And it's 2 times pi times the radius squared plus 2 times pi times the radius times the height. I actually don't like to use that one. I like to use pi times the diameter times the height. I like to think of circumference using diameter and the area using the radius. It sort of helps me remember which is which. And so it's sort of tempting to try to want to remember that formula, but it's not necessary. There's no reason to memorize that formula. All you need to know is that there's 2 circles and there's one rectangle. And the length of the rectangle is the circumference of the circle. And the height is the height of the actual cylinder. So there's no reason to memorize that. Just remember the shapes that you're looking at. So let's see them. So this is find the surface area of the cylinder. I like to write down what I have. So I know that my radius is equal to 4. My diameter is equal to 8. And the height of this is equal to 3. So now I know that I have 2 circles that I want to find the surface area. So it's 2 times the area of the circle plus the area of the rectangle. Okay, so the area of the circle is 2 times pi times the radius squared plus the area of the rectangle is going to be pi times the diameter. That gives us this length here times the height of the cylinder. Yeah. Okay, I'm going to switch colors now. So let's talk about the area in the pink. So it's 2 times pi times the radius squared. So that's 2 times pi times the radius squared is 16, and that is 148 hundredths. All right. Well, now let's deal with the rectangle. So that's pi times the diameter, which is 8, times the height, which is 3. When I multiply all that together, I end up with 75 and 36 hundredths. And when I add the 2 of them together, I get 175 and 84 hundredths. Actually, it says round to the nearest tenth. So 175 and 8 tenths. And millimeters, and since I'm finding area, they're squared. So no memorization. You just need to know the area of a circle and the area of a rectangle. Those are kind of important ones you need to memorize. Okay, so this next one is asking how much paper is used for the label on the can of peas. So in this case, I don't really care about what the area of the top is or the area of the bottom. All I really want to know is what is the area of the actual paper. And so if I undo that, that will be a rectangle where the height is 2 and the length is pi times the diameter. And the diameter is all the way across, so the diameter is 2. So pi times 2. Well, that's not so bad. That ends up being, so 2 times pi times 2. So that is 12 and 56 hundredths inches squared. But that's just finding out what they call that the lateral surface, which is just the actual label that goes around the can. Not too bad. All right, here's a real-life application that says you earn 1 cent for recycling the can in the previous example, the can of peas. How much can you expect to earn for recycling the tomato can? Assume the recycling value is proportional to the surface area. So I need to know the surface area of the 2 cans. So we're going to start off with the tomatoes. So the tomatoes. So that is, I've already worked all this out. That is, it goes over there so I can actually see what I'm writing. Sorry, guys. Okay, so I'm going to start again by color coding. So this is 2 times pi times the radius squared, right? Because this is going to take care of this, of the top of the can and the bottom of the can, because they're both made of aluminum. So we're going to say 2 times 3.14. Oh, actually, you know what? This one is kind of a weird example, because what it does is it actually leaves pi. So you're not calculating what pi is. You're just leaving it as a constant, because we all know it's 3.14. And then the radius squared would be 2 times 2, which is 4. So the surface area of the top of the can and the bottom can is 8 pi. And that's perfectly legitimate to do, is to leave that as 8 pi. It's just a constant. So the lateral surface, or the part that goes around the can, is pi times the diameter times the height. So plus pi, we're going to leave that as a constant. The height is 5 5/10, and the diameter is 4. We multiply 4 times 5 5/10, we end up with 22 pi. And when we add all of these guys together, yikes, we end up with 30 pi. And that's the tomatoes. Well, now let's think about the peas. So how about the can of peas? All right, start with 2, because I have 2 at the top of the can and the bottom of the pan, times the height. And if I go back and look, the actual radius is 1 squared. So this ends up being actually just 2 pi. 1 squared is 1 times 1, times the 2 is just 2. Okay, now the lateral surface of the pecan is pi times the diameter, which is 2, times the height, which is also 2. So when I multiply that, I get 4 pi. And when I add them together, I get 6 pi. So now we're going to have to figure out, we know that the peas we're able to recycle for a cent, so how much we're going to be able to recycle the tomato can. And we can use a proportion to solve this. So we're going to put the surface area in the numerator. And we're going to compare it with the value of the can. All right, we know that the tomatoes is 30 pi, and this is inches squared, by the way. 30 pi inches squared. And the peas are 6 pi inches squared. And we know the value of the can of peas, if we recycle that, is 1 cent, and we don't know what this is. So we get cross multiply, we get 6, why did I write 2? We get 6 pi x. We're doing some cross multiplying here. Then we multiply the other one, and we get 30 pi times 1 cent. Now it's tempting to want to multiply all that out, but I want to get rid of that pesky pi symbol. I don't want it in there. I don't need it. I'm going to get rid of it. And I'm easy. I can divide both sides of this equation by 6 pi. I'm simplifying it before I actually go through the hard part of solving for x. I know it looks kind of weird, but these cancel out. So I end up with x is equal to, pi's go away because pi divided by pi is 1. 30 divided by 6 is 5 times 1 cent. So I would get 5 cents if I recycled the can of tomatoes. Thanks for watching.